Okay, we should be on this page. It should probably be one of the last pages here that looks like this, because we've got one last shape to kind of talk about and explore the properties on. So far we've talked about parallelograms, rectangles, and the rhombus was yesterday. And I kind of alluded that today is going to be the day we talk about the square. Okay, so we're again going to start out with a couple of rotations. And so if you still have your patty paper and you want to use that to help you do your rotations, you can. Some of you may not need your patty paper to do the rotation here. So I give you a minute there to go ahead and do that for those top two problems. Make sure you fill in all the information on the sides and on the angles and everything.
Did you come around to pick these up?
I didn't. Thank you. That's all right. Okay, so hopefully yours looks like mine up here. And like I said, we are talking about the square today. And so just like with those past couple of shapes, we're going to talk about the side properties, angle properties, diagonal properties, all of that stuff. But before we get into that, I just have a question. How many yeses do you think we're going to have today? Just what's your guess? All yeses? You guys feel confident about that?
Yeah, except for one, and I don't know which one.
Okay. So maybe all, but maybe one, or maybe some of you think we're going to say yes to everything today. Why? Why would we maybe say yes to everything on a square?
Squares are cool. Squares are perfectly.
Okay. They're like a perfect shape, aren't they? Everything about them makes sense. Like they all have congruent sides, congruent angles, all those like little details that we've been talking about the last couple of days. When we start looking at them on squares, it just seems to all click into place and just make sense because we're dealing with this shape that's just regular all the way around. When I say regular, I mean they're all the same. Like all the sides are going to be the same. All the angles are going to be the same. It's going to be doing some of that same stuff no matter where you're at on the square. So we're probably going to buzz through these here because we kind of already know that we're probably going to get a lot of yeses here today. The side properties are asking us, are the opposite sides parallel? Are the opposite sides congruent? Do we have four congruent sides? If we look at our shapes up there, all the sides on each one are marked with the same number of dashes, which tells us, yes, they're all the same, which would mean then that opposite sides still need to be congruent if all the sides are the same anyway, and they would be parallel. So we should be able to say yes to all of these. The angle properties are next then. Opposite angles are congruent. Well, opposite angles on our square look to be congruent from the markings. We have some with those 90-degree angle boxes. We have some with the 45 degrees in them. But again, if you look at what corner is opposite of those, it's still matching. So we should still be able to say yes here. Same side angles, those would be those ones like along one of the sides of the square. If you know that like this corner here is 90 and these two here are both 45s, well 45s together would be 90. So 90 and 90 gives me that 180. So we can still say yes. And like a rectangle, squares have 4 congruent angles in them because they're all 90 degrees. So you should be able to say yes again here. Now let's focus on the diagonals. So again, you already have one diagonal drawn in on each of these shapes up above. I'm just going to add in the second one now. And then if we ask ourselves these questions, does it appear that the diagonals bisect each other? Yes, like each little piece, especially on that second one where the lines are straight up and down and horizontal, we can count the squares like we were doing yesterday. Each little piece of the diagonal is 2, so they are bisecting each other. And because each little piece is 2, that means that the full length would be 4 for both of them, so those diagonals should be congruent. It does still appear where those diagonals intersect that it makes a 90-degree angle. So they are perpendicular here at this point, like by M. And diagonals appear to be angle bisectors because even the one that I just drew in on that second shape that's going up and down, on either side of that diagonal it says 45, 45. So that angle is being cut in half. Okay, so if you guessed that we were going to fill in yes on all of them, you were right. Okay, because we are dealing, like we said earlier, with like this perfect shape that we call a square in geometry. So down below, let's summarize everything we've talked about here on our square. So we know that all 4 sides would be congruent. We know that the opposite sides would be parallel and opposite sides would be congruent to each other as well. I'm going to go ahead and just give all 4 sides of this square a dash. And then for the parallel, I'll still draw in those arrows. Like we know that this side would be parallel to this side because those are opposites of each other. And then these other 2 sides would be parallel too. Okay, and again, I just want to reiterate something. Parallel does not mean congruent necessarily. It seems like these last couple of shapes that when we've been marking things with parallel, those opposite sides are congruent, but that doesn't necessarily always play into every single shape that you're ever going to see. Okay, so don't misconstrue that just because something's marked parallel doesn't necessarily mean that it's congruent unless you're dealing with maybe a shape like this one. With the angles, we know that opposite angles are congruent, same side angles equal 180, and that we have all 4 corners being 90 degrees. So on all corners here, I'm just going to write or draw a little right angle box. Then with the diagonals, we said that they bisect each other and they were congruent. So all the little pieces of the diagonals should be equal. So I'm going to give all these little pieces 2 dashes. We also know that the diagonals, when they cross there in the middle, that they're perpendicular. So there should be another like 90-degree angle box there. And again, that would go all around that intersection. So you could put that 90-degree angle box really in any of those spots. And then those corner angles are being cut in half by our diagonals. So the corners all start at 90, which would mean all 4 of them would get split into 45, 45 degrees all the way around. And you could fill that in on any and all the angles if you wanted to, but it's going to be true all the way around that square. Now, when we talked about the rectangle, we kind of focused and maybe highlighted some of the triangles that made up the rectangle. We talked a couple days ago that on the rectangle that those triangles were isosceles. When we went into the rhombus yesterday, we weren't dealing with an isosceles triangle, but we were dealing with right triangles on the inside. If you look at these triangles here, so if I just highlight this one, hopefully you can kind of see it's still a right triangle because of that angle of the 90 degrees where the diagonals intersect. And it is also an isosceles triangle because the diagonals are congruent. So we're kind of taking those 2 triangles that we saw in a rectangle and a rhombus, we're still seeing it in a square, but it's like those properties are kind of morphing together now inside of this shape. Okay, go ahead and turn the page in your guys' packet. You should see this page here that's got this like big chart that looks very much like what we've been working with the last couple of days. But across the top, you can see how it's got parallelogram, rectangle, rhombus, square. So we're going to just take a minute here and fill in only the ones that we said yes to for all of our shapes so that you kind of have all these properties summarized on one page. That way, like in the future, maybe if you're working on like your review for your test, if you're questioning if something is what you think it is, instead of having to like go through all the pages of your notes, you could maybe just come to this page and see, did we mark that one as true for the shape I may be working with, okay? So starting with a parallelogram, we only said yes to opposite sides being parallel and opposite sides being congruent. And we also only said yes to opposite angles being congruent and same side angles equaling 180. And we said yes to the fact that the diagonals bisect each other. Those were the only yeses we had for a parallelogram. Now for a rectangle, we had some of those same properties show up. For the sides, we shaded in the same two for a rectangle on our side properties. For our angle properties, we were actually able to shade in all three. And for the diagonals, we were able to shade in the first two. For our rhombus, we said yes to all of the side properties. We said yes to the first two for angle properties. And for the diagonals, we said yes to the first one and to the third and fourth. The diagonals being perpendicular and angle bisectors. We skipped over that one in the middle because the diagonals were not congruent to each other in a rhombus. And then today for our square, we shaded in yes for everything. So all these boxes need to get filled in for squares. So maybe looking at it this way now kind of helps you see a lot of the properties that all these shapes have in common. And then as we kind of started to get into the more specific shapes, we maybe were able to start adding yeses to things. Which properties were we able to say yes to for all of the shapes? Logan? Diagonals bisect each other. We said yes to everything. Opposite angles are congruent.
Consecutive angles are 180.
Yep. And
then opposite sides are parallel and congruent.
yeah, so there's 5 here that we talked about that are shared with all of them. Like this one. Okay, all 5 of those were shared by all of the shapes that we talked about. Now, as we got into rectangles and a rhombus and a square, we started talking about more specific properties that they share. But you can kind of see like all of those share those same properties that a parallelogram has. Okay, so when I think about how these shapes relate to each other, we could call all of these shapes that we've been working with this week so far parallelograms. Just like we could have called them all quadrilaterals. Like we said, quadrilaterals is like the big title that we give to all the shapes that have 4 sides. And then in that, we started talking about parallelograms first. And then we got into these more individual shapes. But the square, the rhombus, the rectangle, they all share properties with a parallelogram. So all of these shapes are technically considered parallelograms. So down here, I'm just going to write that out. That all these shapes, they are all parallelograms. So a rectangle, a rhombus, a square, they could be called a parallelogram if we really wanted to just be like generic about it. But I can't necessarily call a parallelogram a square or a rectangle or a rhombus because it may not fit into that. Just like on our bell ringer today, we saw that picture of the parallelogram. We weren't able to call that a rectangle because it didn't have 90-degree angles. We weren't able to call it a rhombus or even a square because it had 2 long sides and 2 short sides. Okay? Have you guys ever heard the expression, all thumbs are fingers, but not all fingers are thumbs? Has anyone heard that ever in their life? No? Okay, so let's talk about what that means because it kind of helps relay into this, all right? If you look at my hand, how many fingers do I have on my hand here?
4.
You don't think this is a finger?
Thumb, because it doesn't bend as much.
I still think this is a finger, though. You would be classifying all of these as fingers, right? I have 5 fingers on my hand. Okay, but what do we call this one specifically? A thumb. Do I have any other fingers on my hand that I call a thumb? No. Do I have any other fingers on my hand that I call a pointer finger? Or a pinky? No. So like really we could say this for any of them. Like you have one pinky, you have one thumb, you have one pointer finger, one middle finger, one ring finger. Like they would call your middle finger your index finger. But like you have all of those specific names for your digits, okay? But we all have 5 fingers on our hand. But I can't call all of my fingers thumbs or all of them pinkies. Okay, so that's kind of what I mean here when I say I can call all of these shapes parallelograms, but I can't call a parallelogram a square or a rectangle necessarily. I have to be really specific about, am I naming it correctly here? So down below, I'm going to kind of draw you a little bit of a picture. I'm going to draw like a Venn diagram, which maybe you guys know what that is. It's like when you have overlapping circles or things like that on a graph. So I'm going to call the first thing, like all of this is parallelograms. Okay, all these shapes we've been talking about these last couple of days are considered parallelograms. Now inside of this here, I'm going to draw like 2 kind of ovally shapes, and I want them to overlap there in the middle. And that's where I'm getting my Venn diagram from. Inside of those ovals, on one I'm going to put rectangle. And over here I'm going to call this a rhombus. And in the middle I'm going to write square. So a square is on the innermost piece of my picture here. So a square could be called a rectangle, it could be called a rhombus, it could be called a parallelogram. It could have all of those names because it has all the properties that those other shapes have. Now, a rectangle could be called a parallelogram, a rhombus could be called a parallelogram. But if we have a parallelogram like we did on our bell ringer today, I can't call that a square because it's not a square. Just like I couldn't call it a rectangle either because it didn't have those right angles in it. So that might help you with a visual a little bit of how these shapes kind of relate to each other. They're a little bit like a family of shapes that they kind of have some of these similar characteristics to each other, just like siblings have similar characteristics, or you have some similar characteristics to one of your parents, or maybe even an aunt or an uncle or a grandparent or something like that. Okay. Now, all of these are quadrilaterals. We have not talked about all the quadrilaterals yet. We have one more that we need to get into. We'll talk about that more next week, though. That last one that we're going to talk about is called the trapezoid. He's not really included in this because he's just kind of a little different than all of these other shapes. So, like, if we're calling this like a family tree, he's kind of like the black sheep of the family because he's just a little bit odd. Okay, so we're going to talk about the trapezoid next week and, like, what makes him so different from all of these other shapes. Okay, do we have any questions about squares or this page that we just filled in?